For those of you just joining, thanks for joining us. We're going to get started here, and while we get started, Angie and I are going to do some introductions. So if you wouldn't mind doing some introductions in the chat and let us know where you are connecting from. We are going to be talking about the pacing guide that has been developed for air quality, specifically aerosols. And so that'll be the topic for tonight. And some of you know that we are doing multiple webinars, one for each of the topics of the pacing guides that have been developed. And we'll do a preview of what all of those are at the end. So let's go ahead and get started. And we thought we'd start out by introducing ourselves. So I am Jessica Taylor. I am a physical scientist at NASA Langley Research Center, and that is in Hampton, Virginia. And I'm connecting this evening from Newport News, Virginia. And I have been involved with the GLOBE program for longer than I have been with NASA. So I got to start out doing GLOBE when I was a student at Florida State University. And I really enjoyed making daily observations of atmosphere in particular was what we studied because I was a meteorology student. And I really credit that time of making observations, analyzing that data with really helping me better see myself as a scientist. And so that is one of the reasons I am so passionate about this program and happy to be able to still be a part of it years later now in my role at NASA. So I'm going to pass it off to Angie for her to introduce herself.
So hi, I'm Angie Rizzi, and I've been working on Jessica's team for over 3 years now. But prior to that, I was a middle school educator, and I successfully used GLOBE with my students. I taught for 12 years, and I did all the science in the whole middle school and high school earth science and math every year. And GLOBE was such a wonderful experience for me and my students that it was really an honor to become part of the team where I can help other people learn about it and implement it. So I'm happy to be here, and we can get going into the presentation. So we're going to start with a waterfall chat. Some of you may be familiar with this and others of you may not, and this is very simple. Just put your answer in the chat, but don't press enter until we say go. And this is a very simple question. Do you know anyone with asthma? And we can add in extra respiratory issues to that as well. So I'll give you a minute to type in your answer, and I want to count down. 3, 2, 1, go. And yes, myself, my dad, yes, 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 yes. I'm not seeing any no's here. So that's applicable because if we know people with asthma, then we know that air quality can sometimes be a problem for them more so than it might be for those of us who don't have it. So this is just kind of something that you can keep in mind in terms of why your students might care about this issue. So if we can go to the next slide, please. What we're planning to talk about tonight are the elements of pacing guides that they all have in common. And then I'll go over the air quality pacing guide as I cover some of those elements. Then we'll have a video that demonstrates one of the activities, and then we'll actually let you go and do one of the activities. And then we'll just talk about implementation and some ideas for taking it a little bit further. Next slide, please. So all these pacing guides that we've made, and so far there are 7, are centered around the idea that there's at least one GLOBE observation opportunity in the 5-day pacing guide. There is at least one hands-on activity, and there's at least one activity from MyNASA Data, which is a program that uses real NASA data in their offerings. Okay, so the idea here is that we made tough choices. We put some things together in a sequence of activities, but we very consciously tried to include different aspects of the activities in every pacing guide. So each guide has an overview, NGSS standards that are supported, background information, a 5-day sequence of activities. Like I said, those activities were chosen very carefully, and then additional resources to enable you a little flexibility or customization opportunity. Next slide, please. So on the air quality pacing guide, the overview, it looks a little bit crowded, so we'll go through. The phenomenon is air quality, and in particular aerosols, because there are other aspects of air quality in addition to aerosols. Next slide. The grade level for this particular pacing guide is 6 through 12. Next slide. Next. The guiding question is, how do aerosols affect my sky? Every pacing guide has a guiding question in the overview. And as you'll see when we go through, each day ties back to this guiding question. On the next slide, you'll see that there's a portion of the overview that gives you contact information for our team, as well as pacing guides. And then there's a specific one for the topic. And then the last section has further information on the next slide, where you can participate perhaps in a data challenge or a globe campaign or some other type of initiative if you want to go further. We also have information on becoming a globe trained teacher, which is not required in order to implement a pacing guide. But if you like it and you want to do more, that's always an option. And then there's the link to access all the guides. Next slide, please. So we do align these guides to the NGSS standards. We include all the 3 dimensions and the performance expectations. I will say that we do not 100% meet every standard, but we support them. And you can see the grade bands for this one would be middle and high school. This is not all inclusive. It's just a quick little screenshot to show you how we present these to you. Next slide, please. The background section has background for the instructor. They are welcome to share that with their students. And I'm going to let Jessica share some background on air quality.
Yeah, thanks, Angie. So within the pacing guide itself, you'll see something like this that talks about some of the background. And here, we're going to talk just through some other information that we think will be helpful to you in understanding about aerosols to help implement this pacing guide. And so many of you may be familiar with this color category that you see on the screen here. This is referred to as the air quality index. It is multiple components of what makes up air quality. Air quality it includes a lot of factors, and the 2 main factors here are what we call aerosols, or particulate matter, really tiny little things floating in the atmosphere, as well as ground level ozone. And so this pacing guide is going to focus specifically on the aerosols component of it. Now, as we get into this, I think a big first question is, why is NASA involved in doing this? Well, NASA is responsible for monitoring our home planet. And we do this oftentimes through the amazing views we can get from space. So using our access to space and that technology, we look back at our home planet to monitor Earth. And there are many satellites, as you can see in this animation. All of these satellites that you see here going around are doing some sort of Earth observation. And some of them are atmosphere, but we also investigate other spheres in our Earth system, like hydrosphere, etc. And you can see that there are so many of them, and each instrument is slightly different. And I kind of think of it as your 5 senses, but in this case, many, many senses. Each one is measuring just a little bit differently so that the information can be combined together to help us better understand. what's going on our home planet, which is very important. So let me move on to the next slide here. And this is a really beautiful animation to help give you some perspective as to what a global picture from space helps us with. And that is that it really helps us understand how interconnected our planet is. So these various colors are different types of aerosols. So aerosols can be from natural sources like pollen, dust, sand, sea salt, or they can be from human-caused sources. And you can see that where aerosols originate is not necessarily where they stay, right? Because they get lofted up into the atmosphere, and our atmosphere is dynamic and constantly moving. And so aerosols can certainly originate in one location and travel to another part of the globe. And being able to observe this from satellites and then model this helps us really get this bigger perspective on what is happening with aerosols. Now, I have another video here that we want to show. And this is a quick story about why NASA studies aerosols.
This is an aerosol particle. In real life, you could barely see it. It's just a little speck suspended in the atmosphere anywhere from a few days to several years. It could be dust from a desert, or salt from ocean spray. It could have been blasted out of a volcano, or created during a forest fire. It might have flown out of a factory smokestack, or a truck's tailpipe. Depending on what it is and where it is, an aerosol particle can do some impressive things, like cool the planet by reflecting sunlight back into space, or by collecting water vapor to build a cloud. On the other hand, some aerosol particles trap sunlight and heat the air, thus preventing clouds from forming. Other aerosols can host chemical reactions that damage the ozone layer. And down on Earth, they can even cause health problems such as lung and heart disease. That layer of hazy air pollution above big cities? Yup, it contains aerosol particles. Aerosols, they're tiny, they're powerful. NASA studies them with satellites and instruments on the International Space Station and with specialized aircraft and ground-based devices. Because when it comes to understanding our environment, our climate and how it's all changing, little particles make a big difference.
So hopefully that gives you a little bit better idea
particle.
as to what aerosols are, the role that they play in our health and our environment, and why that's so important to us in better understanding them. So you saw in the video they mentioned that we actually at NASA look to observe aerosols from multiple different platforms. So we do use that vantage point of space, putting instruments on board satellites, but you may have heard mention to the International Space Station. So the International Space Station, the largest man-made satellite, has a number of instruments on it that are also doing Earth monitoring. And there are certainly instruments on there as well that are monitoring aerosols. But we use instrumentation in lots of different locations of our atmosphere, and they talked about airborne instruments. NASA Langley has a huge role to play in putting instruments on board of aircraft, going to certain locations and measuring what's going on in that location. That helps us to test instrumentation, but it also helps us to see how our algorithms, our calculations are working from other types of instruments like satellites. But I want to point your attention all the way down to the ground because we use ground sensors, but there's also a little image in the bottom that says smartphones and citizen science. And this is where we hope you engage your students in being proactively a part of doing the science with us at NASA by participating with the GLOBE program and using the app, Globe Observer. And so why is this so cool to have ground observers in addition to all of these other platforms, right? You think what we've got from space and satellites must be the answer, right? Well, it turns out that satellites do a great job of monitoring the whole Earth, but they do sometimes have trouble with the details. But also, we have very different perspectives. You are on the ground looking up, the satellite is in space looking down. So we need to put these two vantage points together to get a better understanding of what's happening. And let's put this into perspective for aerosols, for example. So let's say a unique event such as a dust storm, or let's say smoky filled skies, that can sometimes be difficult to capture in a satellite image, because if you're using a polar orbiting satellite, for example, that's going around this way, right, polar orbiting, it might not be overhead at that moment where the dust was passing or the smoke was passing, but on the ground you have that unique vantage point to be able to make that observation and to tell us about it through the Globe Observer app. So let's talk a little bit more about how aerosols might impact the sky that we see, going back to that guiding question that Angie talked about. Well, one of the things aerosols can do is impact visibility. Now, aerosols can impact visibility. Can also be impacted by other meteorological variables, such as humidity, for example. But National Park Service, you can go on their website and see some of these really interesting images of different levels of visibility. So visibility here, we're looking along the X direction horizontally, and we're looking at something in the distance to see whether or not it's clear. And you can certainly see in this image, we have examples of very clear days at the far left and hazy days on the right. So what else might aerosols do? Well, our sky reflects predominantly, right, that blue wavelength of light, which is why the sky looks blue. But aerosols are interesting because they reflect all wavelengths of light equally. So they wind up reflecting white, making the sky possibly look milkier, or we're going to say whiter here. So going from a deep blue sky might be clear. And if you had a lot of aerosols, you would have a lot more of that reflection from those aerosols, making the sky look light blue, pale blue, milkier in color. So sky color is another way to be an indicator of what might be in your atmosphere, including aerosols. In addition to those things, which are also really related to our health, aerosols, as you saw in the video, alluding to the idea about how aerosols might impact climate. And in the video, we talked about there are lots of different aerosols, and so they have different impacts on what's going on. And so smaller aerosols, in this case, things like sea salt, they often do a better job at reflecting sunlight. So they wind up cooling the planet. But larger aerosols, like soot or carbon, are usually darker in color as well as larger, and they wind up absorbing sunlight, and so they actually lead to a warming effect. And so for many of these reasons, think about our health, trying to better understand these so we can understand our climate. These are just some of the reasons why NASA is heavily involved in trying to better understand aerosols. And hopefully that gives you a little bit better picture of why your students might be interested in this topic as well. So I'm going to pass it back to Angie so she can go over this particular pacing guide.
So this slide is really in here so that when we share the slide deck, you've got a placeholder. There's a link. The first link is to our partner page, which has links to all of our pacing guides, and eventually we'll have the recordings there as well. And then there's a link for this specific guide. Next slide, please. So as we mentioned, we've now gone through the overview, the standards, the background information. Every guide has 5 days of activities. And this is day 1 for the aerosols guide. And I just want to point out to you, so on the left-hand side, you'll see the activities for the day. And then on the right-hand side, you have some assessment options, as well as a connection back to that guiding question. So every day there's that connection back to the guiding question. And we do have some suggested answers as well. So on day 1, we're saying, what did the sky look like when you made your observation? Well, what you'll do on day 1 is there's a different video than the one we just watched about aerosols, but it is a very good one. It's not that long. And then we have a visibility and sky color data sheet. We're asking you to collect visibility and sky color for 4 days, and also to look up the air quality index. And then if you have time, you can use the Globe Program's Globe Observer app or a data sheet to record a cloud observation. When you make a cloud observation, sky color and visibility are also part of that. So if you go on to the next slide, we will see that there's a video here on how to make a cloud observation. Thank you. So that is your observation, and just to give a little bit more detail on making the cloud observation, we suggest that you want to have your back to the sun, and for the sky color, you would look up at about a 45-degree angle and find the darkest part of the sky that you can find, the deepest shade of blue that you see. For the visibility, you want to look straight ahead at the horizon, also with your back to the sun, and you'll be able to determine. And it may take some practice to be able to classify some of these, but the more you do, the better you can get. So if you make the cloud observation while you're doing the air quality pacing guide, pay special attention to making sure that you do enter in the sky color and visibility. Next slide, please. Again, I mentioned that we're asking you to collect data for 4 days. So there is a data table that you can use with your date and time, and you can use these categories for the visibility and the sky color. It's optional to draw the color, and then look up the air quality index. There is a link in the pacing guide where you can go to find your air quality index at air now. So next slide. When you get to day 2, you're going to build an aerosol sampler, and you're just going to build it and then put it out to collect aerosols. There are 2 versions of the sampler here. One looks more hand-drawn, and the other one is a little more formalized. The activity that we link to uses the one on the left, but I'm going to show you a video on how to assemble it, and it will use the one on the right. It's the same principle. On day 2, the connection to the back to the guiding question is, what do you think you might find on the aerosol sampler? Next slide. So this is me assembling one.
Hi, I'm Angie Rizzi, and I'm from NASA Langley Research Center. And I'm here today to share with you one of my favorite activities, which is an aerosol catcher. So in order to do this activity, you need a few supplies, but they're simple. So you want some clear contact paper, you need a piece of cardboard, and you know, as long as it's as big as a regular piece of paper, it's fine. You don't have to have a specific size. You're going to want to have the 2 sheets from the globe activity, the one which is the sample grid, and then the student activity sheet, which we'll be using a little bit.
If you don't have a printout of the sample grid or the student activity sheet, you're welcome to draw your own. It helps to have a ruler, and you can use blank paper or lined paper or graph paper.
You need some scissors to cut your contact paper, some tape, something to write with, and a number cube or dice. Okay? So we want to do this activity to try to catch some of the aerosols, which are particles that float in the air. Some aerosols are big enough for us to see with our eyes or maybe with a magnifying glass, but some are too small for us to see. So for this activity, we're only going to be able to look at aerosols that we can see with our eyes or with the magnifying glass. So what we need to do is cut a piece of contact paper. Now I've already cut some here, and you just want to make sure that it is big enough to cover that grid. Okay, as long as it's big enough to cover the grid, it's going to be a good size, but not bigger than the whole piece of paper. Okay, then I'm going to take my piece of cardboard, and I am going to take the contact paper, and notice I did not take the back off of the paper yet. And I'm going to put the back side facing up, and I'm going to tape down the corners. And I only want to tape the corners. I don't want to tape all around all the edges. I just want to tape the corners so it will stay on the paper. But that's not sticky. To make it sticky, I have to peel the back off. And when I'm doing that, I'm going to have to get it started. And I try not to put my fingers on the sticky part. So I try to keep my fingers on the corners. And when I get close to one, I will put my finger down and go by. And it's okay to leave a little bit of paper under a little bit of the back under the contact, under the tape. So, okay. So this is what I did. I now have the 4 corners. It's okay to have the back under them. And this is ready to put down and see if it can catch some aerosols. Well, you want to leave it for at least 2 hours and maybe even longer. But let me show you what we'll do after we left it for a couple hours. So pretend that you left it there. And here's my sheet, and here's my sample grid. And I am going to lay the sample grid down on top of the sheet, making sure that the grid is over the sticky part. Okay, I'll stick it to there. And now I will take the contact paper off, and this is why I only wanted to tape down the corners, because it would be too hard to take it off otherwise. And now the sticky side isn't up. But we can go and we have all these squares and we can count how many might be in each square.
Thank you, Jessica. So on the next
I'm
slide,
Angie Lizzie.
once you've done that, the reason that I showed in the video having a dice is because you can, when you go to do your data analysis, you will pick 10 random squares and you can roll 2 dice or roll 1 twice and use those numbers. So if you rolled, let's say, a 2 and a 3, you would look at the intersection of the 2 and the 3. So that's the reason for the dice. And the activity, we link you in the pacing guide to the other activity sheets that you would need. Okay, so for day 3, once you've collected it, you start to analyze, you use your eyes or your magnifying glass, you count the number of aerosols you see in the squares, and your connection to your guiding question on that day is how could the aerosols collected have arrived at your location? So they're starting to think about, okay, we found some things in the air, but how did they get here? Next slide, please. On the next slide, on this activity on day 4 is a My NASA data activity, and the guiding question is, how do aerosols affect sky color and visibility? And I'm going to have Jessica click on the link here. I'm going to give you guys a chance to try this, but I do want to show you a little bit how it works first. So when you go into the My NASA data activity, if you scroll down just a bit, you should see some Google Slides. And when you click on the Google Slides on the right-hand side, the little yellow, yes, there you go. It will force you to make a copy. That is okay. It'll make a copy into your Google Drive that you have, and you'll have this slideshow. Now, if you're using Google Classroom, you can assign this in Google Classroom, or you can use a different learning management system, or you can save this copy. As you go through, I'm going to give you time to go through, but if you go to slide number 3, Jessica, you do need to be in slideshow mode in order to make this work. Okay, so you want to go into slideshow and then you'll click, and each time you click, it's like you're adding a drop of the mystery substance to these circles, and you'll see how the colors change. So you do need to be in presentation mode for that to work. And then as you go to the next slide in this slideshow, it's just going to say, okay, get out of presentation mode now and continue in edit mode. And when you go to slide number 6, there are cylinders that you can drag up under the line there so that you can see the different visibility. So we've got a horizon there for you, and we have spheres that have basically different visibility. So you can see how things would look different on the horizon. There are questions built in, and there are Google Forms that you can use to assign for the students to submit questions, but I just wanted you to see that part of it. And I will put the link for you in the chat so that you can go and spend about 5 minutes on this activity yourself. And then we'll come back in 5 minutes and see what you think about it. Try to get the chat to come up. So here's the link. So if you have any input on that, we welcome that in the chat. The point of that activity, once again, was for the students to think about how might aerosols affect sky color and visibility. Remember that they haven't seen the background information necessarily yet that Jessica provided you with. And we wrote this in such a way that they don't know exactly what they're doing at first, and we kind of lead them through it and explain it as they go so that they can sort of discover that. So that's the day 4 activity. On the next day, next slide, we'll look at the day 5 activity. So you're back to this visibility and sky color data sheet. Remember, each day, hopefully you've made an observation. And on day 5, you will actually try to analyze these data. Now you only have 4 days worth. You do have the option of trying to do this for a longer time period if you wanted to, but you want to be looking at things like, did you see any changes throughout the week? Did you notice differences between sky color and visibility that might have correlated with changes in the air quality index? And the connection to the guiding question is, were there any differences in your local sky during the week that may have been due to aerosols? If so, what were they? But also, very importantly, if not, what would you expect if there were high levels of aerosols in your area? And one thing to keep in mind is that quite often, if there has been rain or precipitation or a storm come through your area, the day after that storm tends to be a very clean day with good air quality. So that would be the kinds of things you might want to be looking for. Next slide, please. On the last day, in addition to the connection back to the guiding question, we also have a connection to NASA. So how and why does NASA study aerosols? I'd like you to put some ideas that you have in the chat. We talked about some background information, so maybe you have some ideas of how and why NASA studies aerosols. And these would be the kinds of things that you can pepper in and make sure that you are mentioning to your students throughout the week. Should we do a waterfall chat for this? I'll give you 30 seconds and then we'll all put our answers in. Okay, 3, 2, 1, go. You guys, you let Jessica answer for you. It's important for our health and for better understanding climate. Better breathing. Thank you very much. Okay, great. So using satellites and citizen science observations, NASA studies aerosols. Very good. Thank you. On the next slide, just to show you, we do have a little answer there in the pacing guide for you. So not to make it too challenging. And then the next slide, just a little sampling of the additional resources. There are more than this for this particular guide, but the idea here is, I alluded to it earlier, we made tough choices and we chose 5 activities. We understand that not everybody is the same, not everybody's needs are the same, and so we do have some other activities that are very complementary, and you are welcome to, swap things out or supplement or do extensions with these activities. We do try to give you an audience idea as well as a description of it, because we know you may not want to click through every single one of them, but they are available there for you if you want to customize this resource. And the next slide is where we talk about how we have tried to make this easy for you to implement because we've done the planning. We've built in these assessment options for you. We've got these guiding questions so you can kind of weave a story throughout without having to do really in-depth data analysis. And those additional resources provide you with flexibility. So we're super proud to be offering these resources, and Jessica is going to talk to you a little bit more about how you can take it even further.
Yeah, thanks, Angie. I think I appreciate you mentioning how important it is that we did make some difficult decisions in choosing just 5 activities for the week. And so you know your students, you know your classroom best. So if you want to swap out some of those activities, drop some of those activities, you do what's best for your classroom. And one of the extension options, since part of making the sky observation could be that you are utilizing the Globe Programs app with Globe Observer. And so we want to make sure that you know this other exciting piece that might happen for you. So if you enter your email in to create your login for the Globe Observer app, you make an observation, you will very likely get an email back to you that is personalized to you from NASA with a table that looks like the one here on the right. And that is showing your observation as well as the information that was collected from any satellites that may have been overhead at that same time that you made your observation. So this is a really great opportunity to showcase your students who are doing citizen science that connection directly back to NASA because you're receiving this feedback. And I think here it's just really important to note what we talked about in terms of having very different perspectives. You're on the ground looking up, satellite is in space looking back down. And so sometimes your observations might be the same as that of a satellite. Sometimes it might be different. And that's okay. And that's what makes it exciting to be able to ask questions about why we think that might be. And so hopefully you find this exciting for yourself and for your students. So with that, we want to thank you so much for participating this evening, afternoon, morning, whenever you're watching this, and remind you that there are a number of other pacing guides, as Angie said. And so if you are participating with us live right now, next week we will be doing a webinar on plants. So the plants pacing guides are going to be the ones that we'll be focusing on. And so that is actually my second favorite protocol in Globe, believe it or not. This meteorologist does love clouds, but phenology is actually one of my favorites. And so it's just a great opportunity to extend and start thinking about the Earth as a system. Also, if you're interested in trying to go now to a different sphere. And so last thing, we just want to open up the floor for any questions you might have. And again, we really appreciate your time and we really appreciate all of the partners who we work with at NASA and throughout NASA Science Activation to help make this possible.